Section 3.6, we're going to look at proving theorems about perpendicular lines. There will be some proofs involved here, but we'll also just kind of use these theorems to set up equations and solve for various angle measures in a diagram. Okay, so understand something. The distance from a point to a line is the length of the perpendicular segment from the point to the line. Critical thing here is if you want the distance between any two things, the shortest distance will always be perpendicular. For example, when you measure your height in relationship to the ground, and you'll never measure your height starting outside your frame of body. In other words, when you measure your height, you go from the top of your head straight down to the ground, perpendicular with the ground. Okay, so again, if you ask for distance, you got to be thinking perpendicular. So a couple different theorems here, and I don't expect you guys to memorize Theorem 3.8, Theorem 3.9, and all of those different things. So the first theorem says if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. Should make sense. Again, if these two angles form a linear pair and they're the same measure, then that means that if we call this one x, this one's got to be x. So x plus x equals 180. So 2x equals 180, and so if you divide both sides by 2, that tells you that each angle has a measure of 90 degrees. Okay, so if angle 1 is congruent to angle 2, then these two lines have to be perpendicular. The second one says if two lines are perpendicular, then they intersect to form 4 right angles. So we already established earlier in the semester that two lines are perpendicular if and only if they intersect to form a right angle. But now this theorem just points out the fact that there's actually 4 right angles. Again, should make sense. If this angle's a right angle, then angle 3 must be a right angle by the vertical angles congruence theorem. And then doing a little bit of math, you know that 1 and 2 here are a linear pair, so they have to add up to 180. If one's 90, the other's got to be 90. That's kind of where the 4 right angles comes from. And finally, if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. Okay, so if I give you a diagram like this, I think it's pretty easy to see here that angle 1 and angle 2 have to add up to 90 degrees. Okay, so given angle 1 is congruent to angle 2, prove that angle QPS and angle 1 are right angles. So I have filled in most of this proof for you. You just got to kind of come up with the reasons. Okay, so reason number 1, always given. Okay, so PS is perpendicular to PQ. Okay, so we know angle 1 and 2 are congruent. So again, all we're going to say here is angle 1 and angle 2 are congruent and linear pair. Okay, now if we wanted to simplify things, we could go back here and say, oh, that's theorem 3.8. Okay, that's theorem 3.8. So these two angles here are congruent and form a linear pair. But again, I don't want you guys to waste your time memorizing theorem 3.8. I will not expect you to know that. Okay, just understand the concept. So now, if I know that angle 1, if I know the lines are perpendicular, that means then that they must be perpendicular. Okay, so I know they're perpendicular. That means that they have to be right angles. I'm sorry. So in other words, once I know the lines are perpendicular, I know all 4 of these angles. Let me mark them all different colors. 3 and 4. I know all 4 of them have to be right angles. So it should make sense then that QPS and angle 1 are 4 right angles, are right angles. And again, that comes from perpendicular lines create 4 right angles. All right, again, we won't do a ton of proofs with these theorems, but we will look at a lot of situations where we'll be solving for things. Okay, perpendicular to a transversal theorem. Again, we've already seen some theorems like this. It says if a transversal is perpendicular to one of 2 parallel lines, then it is perpendicular to the other. Should make sense, right? If I look at the diagram here to the right, if this is a right angle, then this guy's got to be a right angle because they're corresponding. All right, and so it makes sense to say if J and H are perpendicular, then J and K are also perpendicular. All right, so if a transversal is perpendicular to one parallel line, it's got to be perpendicular to the other. Okay, now this one kind of goes the opposite way. This one says if two lines are perpendicular to the same line, then they are parallel. Again, it should follow. Look, you look at the diagram. This angle and this angle are congruent. They are corresponding. If corresponding angles are congruent, then the lines must be parallel. That's the corresponding angles postulate. We've talked about that. So if two lines are perpendicular to the same line, then they are parallel to one another. Okay, so it says write the theorem that justifies the statement. Okay, R is perpendicular to S. Again, that's just theorem 3.8. Okay, we'll just go ahead and write down the theorems in this case to make our life a little bit easier. Okay, a little bit quicker. If you don't know the theorems, just write it out in words. Okay, angle 1 and angle 2 are right angles. See, this is the issue with memorizing those theorems because, to be honest with you, I don't even have those theorems memorized. And so I believe it's theorem 3.9. Let me just double check here. I don't want to give you any misinformation. But again, you know, all I would say here, if it were in a proof or on the quiz, I'm not going to expect you to recite theorem, 3 point whatever, okay? But let me just make sure we have it. So this would be theorem 3.9. Okay, theorem 3.9 says that if two lines are perpendicular, then it forms four right angles, so 3.9. Angle 1 and 2 are complementary, that's 3.10. Okay, and again, don't hound yourself over these. If you're not getting it or you don't memorize the theorems, it's not the end of the world. This is where we're talking, okay? So it says find the measure of angle 1. So clearly here, those two angles are complementary, so the measure of 1 plus 75 equals 90. Subtract your 75 from both sides. So the measure of angle 1 is 15 degrees. Done. Okay, pretty straightforward. Again, now here you have to use a little bit more work, right? If this is 90, that means this is 90 by the vertical angles congruence theorem. So that tells you the measure of 1 plus 30 equals 90. Subtract your 30 from both sides. The measure of angle 1 is 60 degrees. Application type problems. All right, it says example 4 says in the diagram RS is perpendicular to ST. Find the value of X. No different. Okay, if it's perpendicular, that means it's a right angle. And I know those two angles have to add up to 90. So we get X plus 50 equals 90. Subtract 50 from both sides. So X is 40. Okay, notice I didn't put 40 degrees. X is 40. The measure of the angle would be 40 plus 25, which is 65 degrees, but X alone is just 40. And the final example just says find each missing angle in the diagram. Again, you could use a lot of different ideas here. The first one that pops out at me is this angle and angle 6 are vertical. So they got to be the same. By the same argument, 45 and 3 are vertical. So that's 45. And now what I can see here is I know that these two angles have to add up to 90. So 90 minus 45 tells me angle 5 is 45. I'm still going to use my vertical angles congruence theorem here. Okay, and then it's the same argument on the other side. All right, these two angles add up to 90. If that's 50, this guy's got to be 40. And this angle also must be 40 degrees. So just using the idea of complementary angles and then vertical angles congruence theorem a couple times there, and you have found all the missing angles. So again, hopefully this is a pretty good idea in terms of how to use perpendicular lines. We will look at some more proofs in class together and kind of go from there. So if there's any issues with any of these ideas, I have them ready to go in class.